This is our video on A2Pure and its circular measure. So it's our introduction to radians. So when we are working with circular measure, we measure the angle in radians. A radian is defined to be the angle subtended at the center of a circle by an arc length equal in length to the radius. So that's quite a mouthful. So first of all, the first mention would be up to now we've been working in degrees, and you're all very fluent with degrees, you know where they are. There is another way, there are other ways of measuring angles, and the one we're going to look at now is radians. In the same way, if you're measuring your height, you could measure it in feet and inches, or you could measure it in meters and centimeters. A different way of measuring an angle would be either in degrees or in radians. This seems a bit complicated in terms of the way this is defined, but it actually makes life easier for an awful lot of calculations if the measurement is in radians. So a radian, there are pi radians in 180 degrees, and that's the one I always remember. There are 3.14 radians in 180 degrees, and 1 radian is the same as, if this is your radius and this here is also the same length r, that's how you measure then a radian. If you sit and play around with that, you can see then there's going to be pi of them in 180 degrees, and there's going to be 2 pi of them then in 360 degrees. They make your life a lot easier, as I said, whenever you're kind of working out calculations like arc length and areas of sectors and areas of segments and things like that. And so that's what we're going to be working then through this section. First one, arc length. We sometimes kind of call this L. And the arc length is r times theta. That's it. Very straightforward. If theta is in radians, then it's just r times theta. The area of a sector is a half r squared theta. And then the area of a segment, which is this wee bit here, is the area of a sector. Take away the area of the triangle. I hope that makes sense. So let's do a wee diagram here so you can see roughly where this is coming from. Excuse the crudity of my diagram. That there would be your sector. This here is the segment. That's the bit we're looking for. So if you find the area of the sector, take away the area of the triangle, and that will give us that. And the area of a sector is a half r squared theta. The area of a triangle, if this is r and this is r and this is the angle in between, we can use our wee area from GCSE maths. So it's a half times a times b times sine c. I hope you remember that formula from GCSE. So it's a half a b sine c. So in this case it's a half, this is a, this is b, so it's r squared, and then sine theta. We can factorize a few bits and pieces out here, so it's going to give us then a half r squared theta minus sine theta. And those are the 3 formulas then that we need to learn. So L is r theta, area is a half r squared theta, and the area of a segment is a half r squared theta minus sine theta. The other thing is trying to get your head around what a radian is. So a radian is the angle that you go round if r equals r here. So as far as you would go round then from there. This next page I'm not going to spend too long on. It's just proofs for some of the bits and pieces that we've done. It's showing that the length of the arc is r theta, so you can take a read through that. And also the area of the sector is a half r squared theta. Next we'll go on then just to kind of a few other questions. So we need to be able to convert 44.7 degrees into radians. So what do we know? We know that 180 degrees equals pi radians. So 44.7 then. How do we get from 180 to pi? We would divide by 180 and we would multiply by pi. So we're going to divide by 180 and we're going to multiply by pi. And if you divide by 180, multiply by pi, the 3 significant figures, it's 0.780 radians. Part 2, convert radians into degrees. So let's write this the other way around there. We know pi radians equals 180 degrees. So that's 3.14 radians is 180 degrees. So we want 13.2 radians. how do we get from pi to 180? We divide by pi, we multiply by 180, and if you work that one out, you get 757 degrees. Okay, let's move on to a more classic example, I suppose. So consider the following circle with radius 6.5 centimeters. The arc subtends an angle of 32 degrees. Find the length of the arc, the area of the sector, the area of the segment. To be honest, you could do that on a kind of a tough GCSE question. You should be able to work those all out in degrees, but we're kind of trying to move into radians here and try and get our head around what's going on. So the first thing I'm going to do is actually convert this into radians. We know 180 degrees is pi radians. So 32 degrees, how do we get from this to this? We divide by 180 times by pi, divide by 180 times by pi, and if we do that we get 0.558 radians. If this is in radians, it makes our life just an awful lot easier to calculate these things here. So let's take a wee look at what it is we're trying to do. We'll maybe just try and fit it all into one page. Part A, they want the length of the arc, so our formula L equals R theta. The radius is 6.5. The angle is 0.558. So our length then is 3.63 centimeters. That's it. You just need to multiply that by that, and that'll give you the length of the arc as long as your angle is in radians. Part B, area of the sector, half r squared theta. So that's going to be half upon 6.5 squared multiplied by 0.558. And that gives us an 11.8 centimeters squared if you sub that into your calculator. Part C, then it asks us for the area of the segment. We looked a little bit at that in the last bit. So the area of our segment is a half r squared upon theta minus sine theta. Area is a half upon 6.5 squared 0.558 minus sine 0.558. Now we need to stop you here so that you know exactly what's going on. This only works if your calculator is in radians. You hopefully remember from year 10 whenever your teacher said make sure your calculator is in degrees, and that's kind of what I meant by that. So in this particular calculator, if I go shift and mode, 3 is degrees, 4 is what we want, so we want radians there, and then a wee r should appear up there, and our calculator's in the correct mode, and we should be able to then kind of work it from there. So if I type all this in into my calculator, I end up then with 0.602. That then is going to be centimeters squared. Finally then, let's take a wee look at this question. Example 3, it'd be good if you could actually see it. A and B are 2 points in the circumference of a circle, center 0 and radius 5. If the chord AB is of length 6 centimeters, find the area of the segment. Right, so let's see if we can get our head around what's going on here. Something like that. That's 5 centimeters. That's 5 centimeters, and it says in the chord AB is 6 centimeters. Let's call that A, and call that B, and that's going to be 6 centimeters. Find the area of the segment. So we want the area of this wee bit here. Area of the segment, we need the radius. We've got the radius, and we need the angle. So the angle is a bit we need to kind of play around with here and see how we're going to get it. You can do it a couple of different ways. We want this angle here. I'm going to call it theta. You could use the cosine rule because we have 3 sides and we're trying to find the angle. However, because this is 5 and this is 5, that makes it a nice isosceles triangle, and we can just make our life that little bit easier by using simple trig if we split the thing in 2. So if I split this in 2, let's see what we have. That's 5. That's half of theta. And then this is now going to be 3. I hope you can see where that comes from. All right, so we are going to work out our angle here. Once we get this angle, we're just going to use SOHCAHTOA. We're going to times it by 2 then and get this angle here. So let's take a wee look, see if we can make sure we can work it out. Let's label our sides. That is O and that is H. Incidentally, it's just a 3, 4, 5 triangle. You maybe recognize it. We're trying to work this out obviously in radians there. So sine half theta, which is quite awkward, but it's okay, equals 3 over 5. That means a half theta is sine to the minus 1 of 3/5. So a half theta, let's type this in our calculator, see what we end up with. So it is shift sine, we're in radians anyway, 3 divided by 5. And we end up with 0.6435. That's half theta. We want this angle here, so we're going to times that by 2, and we get 1.28700. So let's keep it as 1.287 then, and we can do our sums in from there. So far so good. We've now been asked to find the area of the segment. We're in radians. You notice it's given me the angle here in radians. So let's work it out. A half r squared theta minus sine theta. That's going to be a half upon 5 squared upon 1.287. Take away sine 1.287. Again, remember your calculator must be in radians. If you sit and type that all into your calculator, I believe it gives you 4.09 centimeters squared, and that's our answer then to that.